and welcome to this lesson. This is going to be a bit of a long one, as we're gonna be introduced and we're gonna start working with a new abstract concept that is outside of your norm that you've experienced in your math journey thus far. What we're going to be working on in this lesson is special outcomes when we're solving equations, and these often come up in your once you start solving variables on both sides. You can often have no solutions or infinite solutions. So our goal in this lesson is to identify equations with no solutions or infinite solutions. So we ask, what is a solution? You're asking yourself, what is a solution? So I briefly introduced you in the previous video. What is a solution to this stuff? And I want to make a quick addendum to a previous video at this opportunity. Well, actually, we'll get there. First, let's focus on what is a solution. And we'll get to the addendum from my previous video later. So what is a solution, you ask? A solution is when you can define the value of a variable. X equals 2. That is a solution. Whatever you start with, you simplify it, you isolate the variable, and you're able to define what the variable is equal to in a numerical sense. To put that in short words, a value, or into a pretty sentence for you, a value that makes an equation true. Makes equation true. Equation true. All right. So let me give you, let me refresh another example for you. Let's say that x plus 2 equals 5. So the solution is, and I'm going to spare the details of solving it, is 3. That is our solution. And we can know that this is the solution by plugging it in here, okay? But something interesting happens, and that's the whole purpose of this lesson, is that we learn that while most equations have a solution, some have no solutions, and some have infinite solutions. So let me define this for you. Let's get a couple of terms out here. Let's start with x equals number. Actually, let's erase that. Let's start with this. One solution. We're going to focus on a one solution here. That's what this first one in green is. One solution. That is when x equals number. And one caveat, and this is the addendum from the previous video, it is a number other than 0. Other than 0. Other than 0. That's when you have a solution. Anytime that x equals a number other than 0, you have one solution. If you can make valid algebraic manipulations and get to a number other than 0, you have a valid solution. Now we're going to move to the color orange, and we're going to look at no solution. No solution. So when an equation has no solution, that means there's no value of x that is going to satisfy the equation. And that is going to be when 0x equals number other than 0. number other than 0. Why does that? And let's write that as the word 0 for clarity's sake, 0. And why does that make sense? Well, think about this. 0 times any variable, any x you put in there, is going to equal 0. Now, if on the right side you have 3, and on the left side you have 0x, it doesn't matter what x value you have, you're going to end up with 0 equals 3, which is not true. That is not a true expression. So that is why this is an equation with no solution. So remember, if you ever get 0x equals a number other than 0, you have no solution. All right, let's look at one final case, special case. We have 0x equals 0. Well, let's put infinite solutions. That's our final special case. Infinite solutions. Okay, we have infinite solutions. And that is when 0x does equal 0. You then have infinite solutions. And again, you can think about that. Any x value multiplied by 0 is going to equal 0. So you can pick any real number from any number you can think of and plug it in for x, and you will have a solution. That's why you have infinite solutions. So now that we've went over some of those concepts, let's go through a few examples. Let's switch back to green. Let's go through a no solution example. Let's put some numbers up there and see what this looks like in practice. No solution example. All right, let's say we had 3x plus 5. Let me pause right here. Why am I doing a no solution example and not a solution example? Well, because you have plenty of practice with solution examples. That's why I'm choosing to do a no solution example and an infinite solution examples. So, all right, back to the no solution. We have 3x plus 5 equals 3x plus 1. Now, looking at this as a pattern, I can see that it's going to be a no solution equation. But if you can't, or you don't know, you haven't gotten used to that yet, that is just fine. When you see something like this, your spidey senses should tingle that you see the same variable and coefficient on both sides. And the reason that should make your spider senses tingle is because let's subtract 3x from both sides. 3x from both sides. All right, we get 5 equals 1. Can 5 equal 1? No, I've gotten a nonsense answer. 5 can never equal 1. So when you get that nonsense answer, that means no solution. No solution. Okay? And we can look at that from a different angle. That would be like, let's say, we can manipulate it differently. 3x plus 5 equals 3x plus 1. Let's subtract 1 from both sides. Let's subtract 1 from both sides. And we get plus 4. And we subtract 3x from both sides and subtract 3x from both sides. And we get these two cancel out. These two equal 0. So we have 0 on this side. And these two cancel out. And we have 4. I can go ahead and erase that plus. We have 4 equals 0. So there's two things here. I manipulated it a little differently to get 4 equals 0, which is what the first statement you were shown is. But remember that 4 equals 0 and 5 equals 1 are equivalent, because I could just subtract 1 from both sides. subtract 1 from both sides. So what I want you to realize is that if you get that nonsense answer, 5 equals 1 or 4 equals 0, you have a no solution situation, and that's how you should answer that question. You'll be asked, what's the solution here? You would say no solution. And what that basically means is if they've created an invalid equation, right? If it has no solution, it's an invalid equation, meaning it's not actually equal as an equation should be. Invalid equation. All right, let's move down to an infinite solution example. Infinite solution. Infinite solution. Now this one is going to have a pattern that you could perhaps recognize with practice. And it's going to look like this. 4x minus 2 equals 4x minus 2. Okay? So now there's a little bit of a pattern here. You see that it has the same variable and the same constant. So much like our previous example, if you get there's a rule there. So let's manipulate this equation and then look at the rule. Let's add 2 to both sides. Let's add 2 to both sides. Add 2 to both sides. We get 4x equals 4x. And let's go ahead and subtract 4x from both sides. That's valid, right? We get 0 equals 0. Okay. That checks. That's infinite solutions. Let's try it a different way. Let's rewrite this. 4x minus 2 equals, because what you're going to run into is you're going to make your own manipulations, and you're going to run into something that looks different than what you learned, and you're going to think, well, what is this? That's why I'm doing this example. We get -2 equals -2. So now we have something that's obviously right. And when you have something that's obviously right, that means you have an infinite solution. So, and you could plus 2 to both sides, and you would get 0 equals 0. And there's other ways to manipulate this to get x equals x. Another obviously true solution. So these are some infinite solution examples. So a common mistake that people make when they're doing these problems where they're set up to find something that's a no solution or an infinite solution scenario is they try to force there to be an answer. They try to massage the equations until out pops something like 2 equals x in this situation. What they've done is they kept trying until they made a mistake and then think they have a solution. So don't do that. This is a big mental shift for you, that not every equation will have a solution, and it's a valid solution for you to find that there is not a solution or that there is infinite solutions. So with that said, I'm going to set up a set of practice questions for you. And in this set of practice questions, I want you to either solve the equation or classify it as infinite or no solution. So here it is, the practice set. I want you to solve the equation if possible or classify it in the correct way. Then I'll do the same. All right, let's get right to it. So on the first top left green, my spider senses are tingling. Okay, I'm seeing the same coefficient with the same variable on both sides. So let me follow my standard procedure. Let's subtract 3 from both sides. Let's do that first. We get 2x equals 2x plus 4. Let's go ahead and subtract 2x from both sides. Let's see if we can isolate a variable, 2x. Okay, I have 0 equals 4. These two cancel out, these two cancel out. All right. This is a no solution problem. No solution. Let's move over to orange, top right. All right, now there goes those spidey senses again. But now it's double time because I'm seeing the same variable, the same constants. So I have a feeling this is going to be infinite solutions. But let's work with it and see what we get. Let's add 4 to both sides. Let's add 4 to both sides. We get 5y equals 5y. All right, I already see that this is an obvious. Let's divide by 5. This is obviously true. In fact, let's stop right there. I know just looking at 5y equals 5y, that means any value of y is going to satisfy this equation. If y equals 1, we're going to have 5 times 1 on both sides, and that can stretch on infinitely in either direction on the number line. So this is infinite solutions, and I know that just by seeing what I see now, infinite solutions. All right, so I'm about to scroll down and solve the next two to give myself space to work. So let's scroll down. And we have 2 more to solve or classify. We have 3x plus 6 equals x plus 10. Okay, now this I believe there will be a solution for. So we have 3x equals x plus 4. These two cancel. 10 minus 6 is 4. All right, let's subtract an x from both sides. We get 2x equals 4. And we divide both sides by 2. We get x equals 2. All right, so this is a solution. It gives us a value that makes equation true. Makes equation true. Remember, that's what a solution is. A value that makes equation true. Let's move on up here, top right. Okay, again, I see a pattern here, but if you don't, that's okay. Let's approach this a different. No, let's keep it consistent. I don't want to confuse you. Let's go ahead and actually, I have faith in you. Let's subtract 4a from both sides. Subtract 4a. I have faith that you'll see this and you'll understand exactly what's going on. We get 1 equals 9. And whoa, whoa, whoa. Does 1 equal 9? Not in any math I ever did. So this already I know is no solution. No solution. If I was like a little bit iffy and I just knew that when, well, don't let it get iffy. If you see something that doesn't make sense, it's no solution. And if you see something that can only ever make sense, it's infinite solutions. And yeah, that's the video. It's a big concept. In the next video, we'll start learning to manipulate equations with variables. Keep at it, and thank you for joining me.